Solving this task calls for a function, which is a subroutine that will return a single value as an outcome after it has processed the data that it's been given. The task also indicates that we need to supply a string of hex digits as a parameter to this, but ultimately the value that is returned is going to be a list of numbers. So when we're naming the function, let's call it list as numbers, and let's take in the hex string as a parameter value. We are going to have to iterate through each of the individual characters of hex string. Therefore, we have to consider should we use a for loop or a while loop in the Python language. In this case, a for loop will do nicely because we know exactly how many iterations are going to take place. So let's build a for loop, and we have two choices. We can use the style of for loop that will visit each of the index values, or we could use the style of for loop that visits each of the individual items in the iterable data structure. So hex string is a string, so it's iterable because we can step through the index value 0, 1, 2, 3, 4. In this case, it's probably fine just to use the character, so for every character in hex string, because we're not really going to make use of the index values. Next, we say to ourselves, once we visit each character, say for example the first character in our hex string, what exactly are we going to be doing? So before we begin with the for loop, we're going to need to build a list of numbers, which is an empty list, and then each time we iterate through the for loop, we're going to add one extra value to that list using the append feature. So this means that each time we go through the for loop, we convert the individual hex digit into a denary number, and then we move on to the next one through the next for loop. So how are we going to convert the character? Well, we could be lucky in that the character could already be a numeric digit from 0 to 9. So let's deal with that eventuality first. If the character dot is digit. Now, this function is available in Python for us. There are alternative strategies we could use here in order to work out what exactly the character is, whether it is one of the 10 numeric digits in the ASCII/Unicode character set. But for now, let's just use this and we can come back and look at alternatives later. So if the character is a digit, then it's good to go. We can simply add that character to the number list. So what we can do here is we can say number list dot append, and we're going to add that value to the number list. But we're not going to add it in its textual form, so we can't add the character just as it is. What we're going to do instead is we're going to typecast it into an integer form, and we are confident that this will work because we know that the character is indeed a digit to start with. But in the other event, in the event that it's not actually a numeric value, then we're going to have to do a little bit more work. So in this case, we're going to have to decide what letter is it, and then convert it into the relevant number value. Again, there are alternative solutions here. A basic solution is to set up 6 different branches of one large if structure to deal with each of the letters one at a time. A slightly more elegant, although slightly more complex solution is to convert the letter into its original ASCII/Unicode value and then manipulate it so that it becomes the number that we need. So let's look at the more basic solution first. If the character is exactly equal to the character A, then the number list is going to append the number 10. Similarly, if the character is exactly equal to the B, then we're going to append the number 11, and so on. By the power of copy and paste, we should be able to speed our way through this. So let's do the next one. Let's say it's character C, and start changing the numbers. So it's 11, and then 12, and then we can take these two at once. We can do another. D will give us 13. E will give us 14. And finally we need an else block to say that the other remaining possibility is that it's an F, and that would give us 15. So what the function is going to do is it's going to append either the integer form of the character or it's going to append the numeric equivalent of it. So by the end of the for loop, all of the values should have been appended to the number list, and we can then finish by returning the entire number list, which needs to happen outside of the for loop. So carefully monitoring the indentation, we can see that we are now ready to return number list. In order to test the function, we now need to go to the main body of the Python program and we need to call the function. So let's take the name of the function with the parameter list for convenience. Use copy and paste to bring it down. So when we call the function, we can give it a variety of letters, numbers, and some zero values to be treated as numbers as well. Since this is a function call, we're going to have to do something with the result of the function call, either storing it in a variable or displaying the outcome. And since this is for testing, I'll just jump directly to displaying the outcome. So when we run the program, there we go, there's our list of numbers, and we can cross-reference it and see 490 is fine, A and B form 10 and 11 as desired. And so this has provided us with a working solution to the problem. Let's go back and consider some of the alternative strategies that we could have used. Here, instead of building a 6-part if statement, there was the opportunity to take the individual character as it was and then rewind back to the original underlying number value of the ASCII/Unicode character set and use that underlying number value in order to work out whether this should be a 10, 11, etc. up to 15. So let's go to the end of the if block, and instead let's take the original character and let's pass it as a parameter to the function called ord, which will give us back the underlying ASCII value. Since the underlying ASCII value of the letter capital A is equal to 65, that means that if we were to subtract 55, that would give us the number 10. So let's take the result from the ORD function and let's subtract 55 from it. And let's make that the number that we append to the number list. Copy, paste. Let's save it and then run it and check for errors. A quick look at the two sets of outputs from the previous run and from this run seems to show that they match. Making the window just a little wider so that we can see the full spread of our results alongside our original code. It helps us to see that this has made the program a lot shorter, although arguably slightly harder to understand. Comments are the right thing to do when code becomes a little difficult to understand. So here we're going to convert capital A into 65, then minus 55 to convert it to the number 10. Here we're simply going to typecast the digit to an int. This is going to iterate through all characters, which are themselves hex digits. A further improvement that we could make to the program is to ensure that the original hex string has been converted into uppercase before we go any further. So we can say that the hex string becomes equal to hex string.upper, and this guarantees that we don't bump into a bug where if the given characters are in fact lowercase hex letters, such as lowercase b, lowercase e, that it's going to cause an unexpected behaviour. One final area of concern in this program is that if the user were to be given the task of generating the hex digits, that they may in fact enter something invalid, such as an X. Let's run the program to observe how the program behaves when we introduce an X. So it gives us a highly unusual number of 33 in the middle of our string of digits. Perhaps not the end of the world, but certainly not something that we would want to keep in the program. So it's not clear from the original task whether or not it's a requirement to deal with invalid entries, so we can't assume that the end user is even responsible for generating these hex digits in the first place. They may actually be generated by the computer, and so we could regard it as outside of the scope of the task. If we were to be trying to deal with that, then we would be looking to the if part to work out if everything is sensible. So in this case we would be saying elif, and then we would have to do the conversion if the converted value of the character is in the valid range of 10 to 15, so it has to be greater than or equal to 10, and again stretching this out to make it easier to work with, and if the converted value is less than or equal to 15, then it's good to go. Else we're going to have to pass and skip that particular value because we don't want to add it to the numbered list. We might even do some other gesture as well to indicate that something has gone wrong, but in this case we'll just leave it like that. An alternative strategy would be to add a dummy value into the numbered list, such as a -1 as well. This completes the solution. There are other possible extensions and improvements that could be made, such as replacing the is digit with a reference to the underlying ASCII or Unicode number value of the character itself, where we would ask ourselves if the character value for that is greater than or equal to 48 and the character value is less than or equal to 57. But these sorts of things are perhaps adding to the complexity of the code, and so it's up to you whether you would prefer to read it that way and see that that's what's working, or leave it as the original call to the isDigit function. Finally, just to test it once more, let's rerun it, see how it behaves. And there were no invalid values this time. Let's put the X back in and rerun it again. Yeah, and this time it has just completely ignored the X and not included it in the final list.